Hi everyone, welcome to lesson 6 of our trigonometry unit. Today we're talking about transformations of sinusoidal functions. So basically, what is this? This is transformations. Like in every other unit that we've done, we have vertical stretches, horizontal stretches, a translation, horizontal translation, and a vertical translation. But the only difference between trigonometry and the first few units that we've done, trigonometry just has a few special names next to these transformations. So let's go through our list of transformations. So a in our equation, a in this sine function or a in this cos function, a is going to be the same. b, c, and d. All the transformations are the same, just two different functions. Just a quick note before we get going. Sine function, of course, is going to look something like this. So there we go. Looks something like this. So you have a hill and then a valley, and a cosine function will look something like this. Starting from a hill, goes down to a valley, ends up back up at a hill there. Okay. So that was just from last lesson. So going through our transformations, A is amplitude, and amplitude is always going to be in absolute values. And you have an equation here to find amplitude as well. It's always going to be your max minus your min divided by 2. Amplitude is basically our vertical stretch. If you had a negative in front of your amplitude, again, you can't, there's no such thing as a negative vertical stretch. It's basically you had a reflection and then you have your amplitude. B is your period. And again, B is not the actual period. B is just the value in your equation. Period you have to calculate using either 2 pi divided by your B value or 360 divided by your B value. Vice versa, if you had your b, if you're looking for your b value and you're given your period, you can go 2 pi divided by your period or 360 divided by your period to find your b value. C is new. C is what we used to call a horizontal translation, aka moving it left and right. The name for it in this case here is called a phase shift. Phase shift is going to move our graph left and right. This is the starting point of the sine or cosine wave. Sine starts in the middle going up and cosine starts at the top. So this is going to affect how we start and where we start on this graph. If we shift it left and right, our starting point is going to slightly shift. D is our vertical displacement, and again it's our vertical translation, so D is also new. So we have an equation, well we have two of them actually. Usually we use this one here, max plus min divided by 2. This one here we sometimes use, but D is basically if you take your graph and you split it right in half, that's going to be your vertical displacement line. Um, in this here, this is all related to your two variables up here. To find a minimum value ever, and if you're ever missing it, all you're going to do is take your displacement line and you're going to subtract off your amplitude. To find your maximum, you're going to take your displacement line and you're going to add on your amplitude. The range can always be found by using the formula, and we do have a formula here for range. Range is always going to be your lowest to your highest. Your lowest value is your minimum, highest is going to be your maximum. So lowest is going to be from your D minus the absolute value of A, and your maximum is going to be D plus the absolute value of A. So again, it's just your minimum and maximum value. Um, in interval notation, you can also have the same thing. So it's going to be D minus absolute value of A and D plus absolute values of A. And that's again, if you couldn't figure out your minimum and maximum value, you could have an equation to figure it out. In example number 1, we have the graph of the following. It says graph the following without the aid of a calculator and state all important information. Well, usually if it says don't graph it without a calculator, we're going to try graphing it with the calculator just to see or get an idea of what it looks like, and then we'll try our best to sketch everything else on as well. Okay. So first things first, I'm looking at my x-axis. I notice that it's going from 0 on the left side here, 90, 180, 270, 360, and there's a few extra boxes. So if you take a look at just this first chunk here, between 0 and 90, you have two chunks, so that's going to be 30, 60, 90. So we just broke it up that way. So every box has to be 30 degrees. Going up our y-axis, it's looking like between -3 there almost, maybe even -4, all the way up to +10. So let's set up our graphing calculator. First things first, double check that you're in the proper mode. In this case, we're in degrees mode. I do type in my equation, 3 sine x, close bracket there, and we are going to have that +5 after it. On our graph here, we're not going from -360, the furthest left was 0. It was 360 plus another, so we're going to about 420 there. Going up by 30 is perfectly fine. Let's say we went as far as -4, as high as +10, going up by ones, that's fine. And now we hit graph, and that's basically ultimately what we want to graph out as best as we can. Okay, and so again, even though this question says don't use a graphing calculator, I do want to see what it looks like so that we can try our best to graph it. So that was our graph. Let's use the characteristics to graph everything. So right away, I have an A value, my amplitude. My amplitude is going to be 3. My period, there's no mention of it. There's no B value. And if by default there's no B value, B has to be 1 here. If there's no actual number, B is going to be 1. So our period is going to be 360 divided by 1, which is just 360 degrees. Vertical displacement is going to be this number here. It's going to be 5. Domain we'll figure out after. Range we'll figure out after as well. So first things first, vertical displacement. I'm going to sketch in a line at 5. And basically this line is splitting my graph right in half. That's what it is we shifted our graph up by 5. We're splitting it right in half right there. From there, we can sketch on, because it's a sine curve, 3 above our vertical displacement line. And so our sine curve has to go at its peak, we're at 90, 0 is 180, at its lowest 270, back to 0 at 360. So I'm going to put on a few coordinate dots here. So coordinate dot here at 0, 5. At 90, I'm going to go 3 away from it, so I'm at 90 and 8. 180, I'm back to 0. 275 minus 3, I'm at 2 there. 270. At 360, I'm back to 0. And if I continued on, I would be up here somewhere if I had another square. And I'm basically guessing where that is. Okay. Everything else is just going to follow, is just going to kind of fall in between. And so we have coordinate dots here. This one is going to be, and you're probably asking yourself at home, where is he getting all these coordinate dots from? All these extra coordinate dots now, these I would have just gotten right off my graphing calculator. And would have been something like that. There we go. I'm going to connect my dots. And it should resemble what we saw on our graphing calculator. So just a quick note while I'm sketching this, what you want to do when you're trying to sketch your curves, it is truly a curve there, so don't try to make it too sharp in any one spot. And sharp meaning like it doesn't look like a V somewhere. So basically there you go, that's our sinusoidal curve. What's our domain in this case? Our domain, of course, is always between -infinity to +infinity, aka x is an element of a real. Range in two different ways. So range, let's go with our interval notation first. The lowest we're going to go is 2. The highest we're going to go is +8. So there we go, interval notation done. Range in set notation should look something like this. Y such that y is going to be between 2 and 8. Y is an element of a real. And there we go, that would have been our set notation. On the next graph here, In example B, we have 2 cos x minus pi over 6 minus 1. So again, if I see pi anywhere, I know I'm in radian mode, so the very first thing I'm going to do is switch myself back to radian mode. I also need to switch up my window settings, so the very far left we got 0, the very far right there looks like we're going as far as 5 pi over 2, and this looks like it's going up again. If this is pi over 2, this is 90, so this is 3060, so this is pi over 6 is going to be our first one. So in here, yeah, so we have probably 3 pi basically right down here, right at the end there, that's not drawn on. So let's write down a few things. We have an amplitude, our amplitude's going to be 2. We have our period. Again, period is in front of x there. There's no period. There should have been a 1 there by default. So our period is going to be, in this case, 2 pi divided by 1, which is just 2 pi. We have a vertical displacement. It is minus 1, so that means we went down 1. The one thing that we didn't ask you is phase shift. We have a phase shift in this case here, and I'm going to make note of it. We have a phase shift right here, and we are shifting our graph pi over 6 to the right, because again, phase shift and horizontal translation would have been the same idea. So that means we want to start off at pi over 6. That's going to be our starting coordinate for our cos graph. So pi over 6 is this very first coordinate here. Let's draw in our vertical displacement line first. So vertical displacement was at -1. There we go, line drawn in. From -1, our very first coordinate was at pi over 6. Pi over 6 is going to be 2 away from there, so there we go. That's going to be my very first coordinate dot there. I know that it's going to look something like, well, everything's going to be shifted 1 over at, where are we at? Pi, normally we would have been at our lowest. In this case here, we're going to shift it 1 to the right there. At 2 pi, we would have been right back close to the end. But we're going to be 1 shifted 1 to the right there as well, because again, we shifted everything pi over 6 to the right. To get all the other coordinate dots there, I'm going to go back to my graphing calculator to figure out all my coordinates. So right now I'm in terms of radian. So I do have, oh no, I don't have my graph yet, so let's jot down our graph. 2 cos, we got our x minus, and I use my graphing, or my fraction function, pi over 6 right there, close bracket, -1. And again, window setting, what do we want? We want to go from 0 to approximately 5 pi over 2. We want to go up by pi over 6 on our x-axis. The lowest we want to go is about -4 there. Highest we want to go is +4, going up by 1s seems reasonable. And if I hit graph, there you go. Our graph should match up to something that looks like this. If you really want to see your vertical displacement, you can also add in a -1 there as a y2, and there you go. That's going to be where we split. So the reason why I also add that in is you can kind of see where our graph crosses, or where these two intersect, right? So you can pick out a few extra coordinates. Again, going to our table of values, at 0 we're a decimal there. At this is going to be pi over 6, we're at 1. We're at 0.7 for the next coordinate there, so about 0.7 should have been right here. And then at pi over 2, we're at 0. And again, I'm just picking off all my coordinates here. So at pi over 2, we're at 0. At 2, we're at -1, -2. So at -1, negative 2, then negative 2.7 would have been the next one there. So 2.7 is around there. And now all these other coordinates are just mirroring each other there. 5 pi over 2. And off right around there. So now I'm just going to quickly connect my dots. That first one there. I'm going to quickly connect my dots and come back to you. And here we go. I have my graph done, and does it match our graphing calculator? Again, here's my y1, y2, my window setting here. Looks about right. And there we go. If we graph, it does match up. There we go. So let's fill out our domain again. What's our domain? As far left as we can go is towards negative infinity, as far right as positive infinity. So there we go. Range in both formats. Well, I'm just going to stick to interval notation in this case here. The lows we're going to go negative 3, and the highs we're going to go positive 1. If you want set notation, you could definitely ask, or take a look back at the previous and it'll be something similar. A set notation without the proper notation should have looked something like this in brackets, in your curly brackets. In example C here, we have this equation, and we also want to try to graph this. And again, it's in radian between 0 to pi there, going up by pi over 2. So again, that's 90. If I only have 1, this is now pi over 4. This is now going up by 45 degrees if you're working in degrees. So this is 45, 90, 135, 180. There we go. So first things first, I take a look at this equation. I notice a few different things. I notice that I have an A value, a B value this time, a C and a D value, phase shift, vertical displacement. But notice here, we don't have a dedicated B value. So first things first, I'm going to factor. So I'm going to rewrite this equation as y equals 2 cos, and let's throw this in square brackets now. You have a 2 bracket x minus pi over 2 plus 1. There we go. We factored out that 2, so we have a dedicated b value. So in this case here, what do we have? We have an amplitude of 2. We have a period, and it's not just 2. Our period is going to be 2 pi divided by absolute values of 2 there, which is just pi left over ultimately. You have a vertical displacement of 1, and domain and range we'll talk after. You do have a phase shift, and again, we don't have that on here, but I'm just going to quickly add that on here. Phase shift, and what does that mean? That means we're starting off on a cosine curve at pi over 2. So phase shift pi over 2, and that direction is to the right because it was a negative. So let's start with our vertical displacement line. We want to draw that on. It's on at 1 there. There you go. That's my vertical displacement line. For a cosine curve, it says that we're starting off at pi over 2. So at pi over 2, that's our starting coordinate. So there you go. We should have started there. Pi, period is pi, so that means 1, 2, 3, 4, 4 squares. We should be at the end, so that means every 4 squares I should be at my peak. So 1, 2, 3, 4. That means at 3 pi over 2, peak to peak. And that's all I can fit. If I know that this is peak to peak and that's my start, that's my end, halfway has to be right here, and halfway is going to be from my vertical displacement line down to, that's halfway. There we go. So here we're probably crossing the x-axis on both of those, crossing right here, here on our y-axis, and down here under 2 pi. Again, I'm going to try my best to sketch this graph, and then I'll come back. And okay, I have my graph done. And notice that on this graph here, again, nothing too sharp. Everything is nice and curved, so we have a curve here, change in direction, curve down here, and again, all throughout. And so that's going to be my cosine curve. So let's talk domain. How far left and right are we going? And of course, our domain is always from negative infinity to positive infinity. That's going to be our domain. And our range in both ways, the lowest and highest we're going to go. The lowest is at -1 here. The highest looks to be at +3. So let's write that in interval, which is between -1, +3. In set notation, again, it would have been something that looked like between -1, y has to be between -1 and +3. And again, you would have had your curly brackets and all that there for set notation.